Hello, everyone. So today I'd like to talk about making the most of Wix Data. My name is Justas. I'm a server developer at the Velo platform team. My team is basically responsible for all things in the Wix Data backend. And in this session, I want to talk about how to make most of our product. So as I was making this presentation, as I was preparing, I wanted to best understand what are the challenges, what are the issues that Wix Data users face most commonly, and which places do people generally get stuck on. So I reviewed user tickets that we get internally. I looked at YouTube comments on developers on Wix channel, and I kind of started noticing patterns pretty quickly on. So generally, things like timeouts, unexpected errors are kind of bugging people the most. So I wanted to condense the broad areas to talk about on how to potentially avoid these issues and what to focus on when you're using Wix Data API. So I want to explain a little bit on how I chose what topics to cover. So I wanted to, as I mentioned, go over these common roadblocks, go over kind of issues in the setups or issues in usage of the API. But I also wanted the presentation to be useful to both new and existing users. So to existing users, it's likely that you'll see and relate to some of the issues that I'm covering here, potentially also see ideas of improving your workflow. And to new users, the hope is that you'll be able to see the optimal way of setting up your collections, your queries, and avoid the pitfalls that maybe a less experienced user might face. So I want to talk a bit about what I'll cover today. So I separated out my talk into four main areas. We'll start with data modeling and retrieval. So this is everything from the schema of your collections and how to build it in a way that's best for you. And then retrieval is the querying part, how to make your data retrieval fast, how to make sure that your queries don't take longer than you expect. After that, we'll dive a bit more into kind of performance side of things, and I'll talk about indexes. And indexes are a recent functionality that we've opened up to all users. And I'll show you the big performance gains that you can get in a matter of minutes. And this is something that people will be able to include in their sites even today. And it really is very simple. And I'll show you how to do that. Then kind of switching from the performance topics, I'll talk about security. More specifically, what kind of functionality, what kind of features we give for our users to deal with data security and things there that we provide. And finally, I'll talk about limits and throttling. So this is quite a common theme that I noticed over as I was preparing. People are getting users of the API are getting throttled unexpectedly. They're hitting timeouts, and a lot of these issues are fairly simple to resolve. And I'll talk a bit more about why we throttle in the first place and the solutions to avoid that. So let's start with modeling and retrieval. So the first thing when you're using Wix Data API, the first thing you need to do is decide on how your schemas will look, how your collections will look. And this is something that is worthwhile kind of taking a step back and not rushing it. This is kind of the pillar that the entirety of your Wix Data experience is gonna rely on. So when you're planning your database model, it's I would even suggest taking pen and paper and kind of answering some of the fundamental questions about your site, like what is the purpose in terms of information, what will be stored and shown, what data will be needed most often. So the data that's needed most often will be your most important collections probably, and you need to think about maybe the different entities that you're going to display. Are they going to be displayed together or separately? And that can answer questions whether it makes sense to put things in the same collection or separate them out. The main goals when you're planning a database model is performance. So you want your most common queries to be fast, and also avoiding duplication in your data, avoiding inconsistencies. So you don't want the same data living in several different places, because then you have the headache of making sure that it's always kind of up to date. So you might go out of sync if you only update some of the places where the data lives. Additional benefit into doing a good database model is future flexibility. So it's possible that over time the requirements of your site change in some way, and likely you might need to extend your schemas. So doing a good job of initial modeling will make that easier and make your models more flexible. So one particular area that I want to cover here is referencing and how to make use of references. So to give a bit of context, I want to explain the concept itself. And in the top here, in the top right, you see a picture where we can see two collections. So artist collection is the one on the top, and in the artist collection, it's a very simple collection. We have a name and a picture, and on the bottom we have songs collection. So songs collection has the song title, and it has the special artist field, which is a referenced field. And what does that mean? It means that in the songs table, in the songs collection, the artist is actually it actually points to the first collection of artists. So then let's say if I change the artist name, like let's say I have typo in Tom Petty, if I fix the typo, it's gonna automatically fix in both of the songs of his in the songs collection. So I only have to update, like I only have to update the name or the photo once for it to replicate in the songs collection. So this allows or this enforces data integrity, because I won't have potentially like different pictures or different names for the same artist, because it always refers back to that single original entry. This also avoids data duplication. So if I want to change the picture, as I mentioned, I only have to do it once in the artist collection, and then it's going to automatically update in my songs collection. And this avoids the duplication problems and having to maintain that. Additionally, it's very easy to use this data from different collections with Wix's UI elements, such as tables, galleries, repeaters. And as an example here in the bottom right, there's a table that I added through the Wix UI, through the website builder. And as you can see, I have a table with 3 different columns. So the song title actually comes from the songs collection, but the artist name and the artist photo come from the artist collection. And so I'm basically putting data here from 2 different collections. And the reason is it's so simple to do is because of referencing. And the UI elements here allow to they allow kind of really simply adding data from collections if they have this reference relationship between them. And as you can see here, the song title, let's say, is Free Fallen, and then the artist name and the photo are taken from the artist collection in the very top. So when we're talking about performance, what is it generally that makes queries slow? And this is something that this is something that's I saw in patterns reappearing as I was looking into clients issues, as I was looking into questions that were posted online. So one kind of general theme is not being not paying enough attention, I suppose, in the requests, in the queries that are being made. So this is the first 2 points that I have in this slide. It's like potentially including fields that will be ignored. So including referenced entities and not using them in the query result. And this is essentially a waste of resources, because adding that referenced entity takes up extra time, but it's not used. So we could have returned the query, we could have returned the result faster, and nothing would have changed from the user experience. Additionally, using larger than needed limits. This is a similar fashion, potential, like as an example, you might have a query that tries to get 1,000 items to show them in your homepage, but in your homepage you actually have space for 10. So the 990 items are fetched for really no reason, and this is again it's much slower for the user. It's slower in the database to fetch the 1,000 items, but then also there's the bandwidth cost, especially for slower connections. You need to download all of those 1,000 items, even if you're not showing them, which adds to the slowness and the bad user experience. One other interesting trend is that I've noticed in some cases is keeping dead data in your collections. So this is a bit more specific. This is for collections where items are added over time, so the collection size grows. And there's cases sometimes where you know for sure that some of the items in your collections will not be needed. Like, say, for example, you have a collection where you only deal with items that are less than 1 month old. So what you could do is kind of have potentially a scheduled job or something like that, where you would remove the data that you know will not be used. So you're only keeping fresh data that is going to be useful in your collection. This will speed up all of your queries, because generally what queries have to do is scan over items in your collection. So if your queries do not have to scan over this kind of dead data, it will generally be faster. And this can go to really extreme cases where some 90% of your data is never used, and all of your queries are doing way more work than they're actually necessary. One final thing is a bit of maybe less known functionality in our API is the bulk operations. And we have operations like bulk insert or bulk remove, where you can achieve, let's say, adding 1,000 items into your collection with just a single request into our API. So a single network request. And this is going to be much more optimal than looping and doing these requests yourself. And it's going to be much more much faster, generally much more efficient in the database. And doing these kind of operations, this manual looping yourself, tends to be very slow. And this is bulk operations are generally a bit underappreciated, I guess. So one particular case that I want to talk a bit about is aggregates. So aggregates are a special type of query that are used for these kind of analytical queries, a bit more complex, where you might need to maybe sum over something or get an average of something, and it allows for things like grouping, sums, allows combining multiple of such aggregations in the sequence. So it provides this composable, powerful API, and it's generally faster than writing this kind of code yourself. Let's say if you want to get an average price of all of your orders, this will be the best practice to do those kind of queries. And I want to show an example of this. So here I wanted to have a really simple collection with just a very trivial example, but to get a feel of how this works in practice. So in the bottom here, we have a collection of population data. So as you can see, there's 2 cities in Florida, 3 cities in New York. And what we do in the query is we group all of our entries by state and then get the maximum population for each of these groups. And as you can see, the result is for Florida, you have a population of 902,000. So that's the population of Jacksonville. And for New York State, you have the population of over 8 million. That's for the New York City. So as you can see, this is a very trivial example with just 5 entries. But the idea is that you can do much more advanced things and make this aggregate query as complex as you like. Before moving on, I want to also mention using logs when you're dealing with existing queries and potentially trying to find slowness in them, trying to see which of your queries take the most time. So I wanna advocate for using logs for that. And we have site monitoring functionality for all of our Wix websites. And what you can do there is you can view sites events in real time, so you can see all of the logs that are produced by your site. Additionally, what you can do is connect this to a third-party service like Google Operations. And what happens there is that your logs are getting collected over time. So then you can you can collect them for a while and then see what's happened, let's say over last 7 days in your site. So if you're able to connect to these tools, then you can gather events and get visibility into site's health, and you could potentially see how slow or quick your queries are, maybe what functions are timing out in Velo backend. And there will be more on this topic in the dev lifecycle talk in Wix DevCon. So now I want to kind of keep on this performance topic and talk a bit more specifically about indexes. So in general, indexes are a tool to improve speed of your data retrieval, so speed of your Wix data queries. And the naming comes from kind of analogy to a textbook index. So in the textbook, if I have a particular topic that I want to see, I won't look through the entire book. What I'll do instead is I'll go to the back of the book and look at an index. In there, I'll see which precise page is my topic on, and then I'll just open that page and find what I need. So database index work in a pretty similar fashion. So if you have an index, rather than scanning through the entirety of your collection, index might be able to suggest where to look for the data that's going to be useful for you. And in this way, you're able to speed up your queries by removing a lot of unnecessary scanning and work. So what can they do for you? As I mentioned, improving performance, that's probably the most what people are most excited about. Additionally, it can enforce uniqueness in your fields, and this is very useful for dynamic pages. So in dynamic pages, to use that functionality, you had to ensure field uniqueness by yourself previously, and this is something that it takes manual effort and time to do so. And now what you can also use indexes to have the system validate this uniqueness of fields for you, so you can spend less time on that yourself and give the entire responsibility to the system. So when talking about best practices of building an index, so it makes most sense to index fields where equality is compared frequently. The more diverse range of values, the better. So the more diverse range of potential values, the more redundant or unnecessary work is kind of thrown away. So you're reducing your search space by more if you have more diverse values, which in result speeds up your queries. So in an example here, we have a query over products, and we validate or we compare equality against category and origin. So both category and origin could be potential candidates for an index here, potential candidates for an index field. And in reality, what might make sense is going over the data, just taking a look and seeing which category, which field actually has more diverse values, and that could be the index to apply here. So if there's more countries of origin than categories of product, it might make sense to go with origin as your index field. Additionally, you should consider how you sort the data, and having that in mind, it can also bring up good suggestions for index fields. Let's say if for products, if we sort by price, it can also be a good candidate for index field. So really, depending on the usage of depending on the queries, the types of queries that you're running, all three of these fields, category, price, and origin, may be good fields to index on. It really depends mostly on the way you're using them and the values that this data may have. So now I want to show a real example of what a simple index can do. So I made two identical websites. The only difference between them is the coloring, but also the index on the right, the green website. Sorry, the green website on the right has a collection that is indexed, whereas the one on the left does not. So, and both of them have absolutely identical data with just over 1 million entries. The data itself is trivial. There's only two fields in each entry. There's the title, which is a string, and an author, which is also a string. So now I want you to see how performant the queries are. When I do a simple search. So as you can see here, I'm looking up by author name, and the first query takes almost 2 seconds. I then do a bit more a complex search with both title and author name. As you can see, there's one result that got returned, and it took 1.7 seconds. And then I'm doing the third search, but actually, as you can see, there's nothing that came back, which means that the query timed out completely. So now I'm going into the editor, and I want to show you how this collection looks in Content Manager. So as you can see, there's 2 fields in data. And if you click more actions, there's indexes that you can, indexes for this collection that you can look at. And for this particular collection, we don't have any indexes on it. And I'm showing now how to add one yourself. So here you can choose the type of an index, choose the field or fields to index on. So here I'm indexing the author field. And in this case, because the collection is so large, over 1 million items, indexing can take potentially 20-30 minutes here. So what I've done instead is I built an index beforehand for the same collection in this different site. So now I'm just going to Content Manager to show you that. So you can see that the author index for demo is built, and it has author as the field that it indexes. So now when I do the same search by author name, the same query takes 10 times less, so around 200 milliseconds. If I do a bit more complex search, also using author name and the title, it takes around 200 milliseconds as well. And just to show you that it's not a fluke, the third query does it in 162 milliseconds. So just adding this one index sped up the queries here around tenfold, which is really an incredible amount of speed up and performance that you get by just doing the simple task, the simple action of adding an index to your collection. So now I want to move on from performance side of things and talk about data security. And just to give some context, in general, data security, web security is something that's crucially important for Wix. And it's something that Wix looks at very seriously. And obviously, like, we would, as a company, would go out of business if we didn't do that. But additionally, what we do is also give you some of the functionality to better secure your data in the way that you want. So one way to do this for Wix Data is making use of permissions. So for each collection, we allow setting these fine-grained levels. So you can, for each collection, you are able to choose who is able to do what actions on your data, and you can be really specific. So for a particular collection, you might only enable yourself, the site admin, to view and write the data. For a different collection, you might do something different, maybe even allow anonymous users to see it. So you can be really specific with it. And it's a good practice to go over these permissions and think about who will be using this information, and making your permissions as strict as they can be. So for each collection, think about where you're showing it. Do you want people to modify it? Things like that. Makes a lot of sense to go over and review whether the permissions that you have are sufficient and acceptable for you. By default, the permissions are set to be quite strict, but it's always a good idea to take a look at them and review. Another functionality feature that I want to mention when we're talking about data security is Wix Data hooks. And hooks let you run code before or after Wix Data operations. So there's a lot of interesting use cases that are supported by data hooks. One idea is you can validate data before you insert it into a collection. And this is the example on the right here with some code. So you can see there's a before insert function on my collection. So this is, we would call it a before insert hook. And what it does is when you're calling Wix Data insert, before this item actually gets added into the database, we would run this function and do whatever's in the body of it. In this case, we validate that item.email is a valid email. So it's a valid, it conforms to this regular expression in the bottom here. And if it's valid, then we just return the item unchanged. If it's not, then we return rejected promise. And in response, what would happen is the insert would fail to the user with this error message, invalid email address. So in this way, it can be used as a security measure. If you have this data hook in your collection, you can be guaranteed that all of your items, all of the items that are added to this collection will contain a valid email address as per your function. Data hooks also allow other use cases, like, for example, you can track popularity of items. So potentially you could do something like an after query hook, where you update each item with some counter, and if an item gets queried, you increment the counter, and then what happens is that you have counter for each of your items with how many times it got queried. So it can be you can get quite creative with hooks, but it's definitely very useful as this kind of extra security measure that you can really customize to your needs. The final topic that I want to discuss today is limits and throttling. And initially, I want to give a bit more context on why we throttle in the first place. So why do we sometimes reject or impose a timeout on the requests of our system? So main idea is that Wix Data is a system that supports millions of sites, and it's a multi-tenant system, and we want to make sure that all of the tenants, all of the users, play nicely with each other. So we want to avoid this noisy neighbor problem, where one of the tenants kind of steals all of the resources and makes the system worse off for the rest of the users. So we want to protect system health. We want to ensure that the user experience is good overall for all of the users, and we do this by the way of imposing quotas to ensure that users are not abusing the system. So we have several quotas that we maintain in the system. I will not go over will not go in depth on each on it, but I just want to mention them here. So we have quota for too many requests. So this is just sending a lot of requests, like a burst of requests in a short amount of time. We also have individual request timeout. So for each request here, each request in Wix Data, we have a 5-second timeout. If you exceed that, then automatically your request will fail. And we also have overall processing time quota, which is, you can think of it as the combination of the first two. And I will go a bit more, will go into a bit more detail on this one. So overall processing timeout exceeded is really measuring how much resources you use over a certain period of time. So if you do a lot of queries that are also heavy computationally, it's very likely to hit this quota. If you're using quick queries or not doing a lot of queries in a short amount of time, then it's less likely to exceed this particular quota. So I want to mention a few tips on how to make it less likely to, how to make your site less likely of hitting it. And the first idea I have in mind is using paging and generally delaying the loading of data. And so this is on the right-hand side, the picture here. Instead of loading all of your items at once, let's say instead of loading 15 items or something in your homepage, what you can do is make use of paging. And this is also simplified if you're using things like galleries in Wix's editor's UI. So what you can do here is show a small number of items initially, and then wait for explicit user click, in this case, either like load more or next page, to load up more items. So this will reduce the amount of work that the database has to do, and the amount of data that's being requested. And you'll be sure that the data you request is actually needed by the user. Additionally, index your most used collections. So indexing is useful for the site because it's the queries are going to be much faster. The user experience is going to be way better. It's also useful for the system because the queries are computationally much more efficient and use less resources. So indexing your most used collections will greatly reduce the overall processing time of your queries. Additionally, simplify queries if possible. So this would involve kind of reviewing the queries you're making, seeing if you're not doing additional work, not including items that are not needed, whether your limits are sensible, things like that. And then also the bulk functions that I mentioned. If you want to add or remove a lot of items at once, make use of the bulk functions because they're much faster, and the overall processing time of them is going to be way less than looping over regular requests yourself. So some people may now think, okay, these tips are legit, but I've actually implemented all of them, and my site is still sometimes hitting these quotas. So is there anything that Wix can then offer for me? And there is. I've pointed out a couple of solutions for these more advanced applications where the amount of data, the amount of bandwidth is much higher than majority of the sites. So one way is getting your site a quota increase, and we call it VIP sites, VIP sites. What you can do is basically, as a premium site, reach out to us, and we just increase the quota of all of the quotas that I mentioned. We increase it, and you're less likely to hit it. But there's no performance improvements or anything like that. It's a simple increase in the quota, so you get a larger slice of the resources, basically. One other potentially useful way to resolve this is external databases. And this is essentially connecting your own database with Wix Data. So in Wix Data, we have a bunch of adapters where we kind of glue together your database and the Wix Data API. So you, behind the scenes, you attach your own data source, but then you're able to use the same API without kind of any changes on the code. So the very useful thing about connecting your own database is that now we don't impose request timeout quota and the processing time quota, because this is not a resource that's shared, so we don't have this multi-tenant problem. As long as your database is able to handle your site's traffic, your site's data load, we're not going to impose any throttling or on our end. So potentially this can be much more performant and high and handle much higher data loads than what you would get with our initial multi-tenant solution. So these are the topics that I covered today in making most of Wix Data API. I started with data modeling and retrieval. So I talked about what to focus on when deciding on the schemas of your collections, how to make sure that your queries don't get unnecessarily slow. Also mentioned aggregation for more complex analytical queries and making use of logs to monitor your site's health. I then talked about indexes, and again, I'm emphasizing to try this out on your site even today. It's something that takes really a small amount of time to do, and as you saw in my demo, it can increase your performance in a very visible fashion. So in the site that I had with over 1 million items, my simple search queries went from 2 seconds from even timing out to around 150 or 200 millisecond. So really an incredible difference there just by adding an index. Then I talked about data security and what we provide there for our sites to customize their data security and improve it. So we have things like permissions and data hooks that you can make use of to have a better to better enforce and restrict your data access or your data cleanliness. Finally, I went into limits and throttling. So I explained a bit about the nature of our multi-tenant system, where we have a lot of users. So we have to make sure that everyone plays nicely and the resources are shared among them. And I also talked about the advanced features like connecting your external database for more advanced users. An external database can then let you potentially handle much higher data loads on your site. So that's it from me. I want to thank everyone for taking the time and watching my presentation. And I'm curious to hear if anyone has questions on making most of Wix Data. If you do, I hope you can leave them in the comment section below.